F2 is giving us 10 Newton, 90 degrees from the north, and then F3. This is 25 Newton acting at 180 degrees from the north. So we are to determine the resultant force and then the direction of this resultant force. Now, what is a resultant force? The resultant is a single force whose effect is equal to the combined effect of a number of forces. So all that we are saying is that we are looking for that single force whose effect will be equal to the combined effect of this one, and this one. That is the meaning of resultant, the resultant force. Now, for more than two forces, you must resolve each force into its vertical and then horizontal components. So if I pick F1 acting at 18 Newton at an angle of 360. In fact, it is always convenient using the angle it makes with the y-axis, not on y. It is always convenient when you use this because 330, for instance, from the north, this is 270 plus 60 would usher me into 330, 18 Newton. 18 Newton. So the angle to add to 270 is 60 degrees. Now I can easily resolve this using 18 Newton sine of 330, 18 Newton. The Newton is even not so important. Then 18 cos of 30 degrees. And this must give me the x and y component of the force 18 Newton. Now, if I still want to explore, then this is also equal to the angle it makes with the x-axis 60. So 18 cos of 60 degrees. But in using this approach, you must know the quadrant within which x falls. This x falls along the negative x-axis, and so it's negative. Then the vertical would also be 18 sine 60. And 18, the vertical falls within the positive y-axis, and so that is positive. Another way to do the same thing is also to use the angle it makes with the y, 30. So there are lots of ways to look, okay, or to go around this thing. Please, are you with me? Is somebody with me?
Yes.
All right. Okay, so cos 60 is half. So this is equal to -9. So if you point 18 sine 30, what you get is the same as minus 18 cos 60. Then sine 60 or cos 330 is root of 3 on 2. So this will also be equal to 9 root of 3. You can express it in decimals. You are not wrong. Then let's look at F2. Let's look at F2. F2, the angle is 90. When I draw, it means that the vector lies on the horizontal axis. This is 10 Newton. Because this angle is 90 degrees. Leonard.
So please, I wanted to ask whether we are solving the assignment you gave us last night.
Pardon?
I was asking whether we are solving the assignment you gave last night.
Exactly. Okay. So if you are to use the angle it makes with the y, we have 10 sine 90 and then 10 cos 90. I repeat that the angle it makes with the y, the order of the coordinates is a sine cos. If you are using the angle it makes with the x, it's cos sine. Now, what is the angle the force 10 Newton makes with the x-axis? What angle does it make with the x-axis? Yes. What angle does the 10 Newton makes with the x-axis? Anybody? Joe, let's hurry up. What angle does this force makes with the x-axis? Lizzie, Leonard, and Co. Respond. Or you don't know? Are you there? Joe, I need response from you. What angle does this force makes with the x-axis? Okay, so the force lies on the x-axis, direct. If my hand is the x-axis and the other hand is the force, yes, the force exactly lies on the x-axis. And what angle does it make? What angle does it make? Okay, so it's 0 degrees. The force is parallel to the axis. The force is parallel to the axis. So it makes an angle of 0 degrees with the x-axis. So if I'm resolving this force using the angle it makes with the x-axis, it is equal to 10 cos 0 and 10 sine 0. This is the other way to look at it. Now sine 90 is 1. So this is 10. Cos 90 is 0. So this is 0. If you look at cos 0 is 1. So this one will also give you 10. Then sine 0 is also 0. And this, so both ways would give you the same results. Please, are you okay? Are you okay with the explanation?
Yes.
All right. So the third one, the third force, F3, 180. This is 25 sine 180, 25 cos 180 degree. Okay. Now what is sine 180? Sine 180 is 0. So 0, and then cos 180 is -1 minus 25. Okay. Now, if you want to use the angle it makes with the x-axis, this makes an angle of 90 degrees. This is the direction of the vector, 25. And the angle it makes with the x is 90. So I can also resolve this using the angle it makes with the x. So 25 cos 90 and then 25 sine 90. However, the y component is a negative, falls along the negative y-axis. And so I must negate this. And it will be the same as using the angle it makes with the y. So these are how to go about
Sir, please
this
come again.
problem. I'm coming. So we are looking at either the angle it makes with the x-axis or the y-axis. And when we look at this, the angle it makes from the y-axis, from the north, is 180. And so if I'm using that angle, I have 25 sine 180, 25 cos 180. You can also look at it from this angle. The angle it makes with the x-axis, either this one or this one, because the force is along this direction. If I use the angle it makes with the x, this is 90 degrees. But don't forget, when we are using angle to the x, the order is cos and sine. So we have 25 cos 90 as against 25 sine 90. Now, the y component falls along the negative y, so you negate it. And when you negate it, either the angle it makes it y or x would give you the same results. And that is what I'm saying. All right. So we have resolved each force into components. Okay. So let's clean it and then write it for the various x and y component of each force. So F1 we have -9 9√3. Of course, we can also write this as decimals. Then F2 we have 10 0. F3 we have 0 minus 25. So determine for summation of all x's. We are -9 plus 10 plus 0. And this is equal to -1 Newton. Then summation Fy. We have 9 root of 3 plus 0 minus 25. What is 9 root 3? Give me the value of 9 root 3 in decimal. So we have 15.59. And when you subtract, you have minus,
Negative 9.411.
okay. Today my voice is down a little bit, so be attentive and then be doing a contribution. Now, what I realized was that some of you were ending here, and the conclusion is that R is equal to summation Fx plus summation Fy. A very big error. And so I saw -1. Sorry, this is 1. 1 minus 9.41 and 8.41 Newton. A very big error. Okay. When you get to this point, you draw on the XY axis. Your summation Fx is +1. So it will be along the positive X. This is summation Fx, which is equal to 1. Summation Fy is a negative value. And so it must be directed along the negative Y. Now here too, I saw some of you indicating minus 9.4, which is also not correct in the sense that why did you bring it down here and not up? You brought it down because the line or coordinate is negative. So the moment you bring it down, it has taken care of the negative to the value of summation Fy. The moment you direct it down, the negative has been taken care of. Please, is that okay? Hello? So you don't repeat the -9, no. So you resolve to get the direction, equal vectors. 90. So obviously, the direction will be here of the resultant. Then you use Pythagoras theorem to find R. R squared equals summation f of x squared plus summation f of y squared, which then becomes 9.1 squared plus 9.41 squared. This is 1. What's the square of 9.41? What's the square of 9.41?
Sir, 88.5.
Okay.
88.55.
Is that 8.55?
88.55.
88.55.
Okay, so we have 89.55 Newton. So that R is equal to the square root of what's the square root of this? 89.55.
9.46.
9.46.
Now the direction. Be attentive to the direction. This is, you see, the resultant force acts within the east-south direction. And so the angle it makes, determine this first. The angle it makes with the x-axis or the east. So assuming the angle is alpha, because I have the opposite, the adjacent, I can use tan of alpha, which would be equal to 9.41 over 1. Alpha, therefore, is equal to the tan inverse of 9.41. And what's the tan inverse of 9.41? What's the tan inverse of that?
83.93934.
So approximately 84. What it means is that the resultant makes an angle of 84 degrees from the east or from the x-axis. Now, conventionally, because angular measurement is taken from the north, we can also determine the direction from the north. Now, to determine the direction from the north, this is an angle of 90 degrees. So 90 plus what we have, 90 plus 84 would give us the angle it makes from the north. Okay. And this is 174. So 84 degrees from the east or 174 degrees from the north becomes the direction of the vector. That's all. So those of you who did not get that part, this is how to go about it. 84 degrees from the east or 174 degrees from the north, because conventionally we are always measuring angle from the north. So this is how to determine the direction. Okay. All right. Today I want us to look at equilibrant of a force. The equilibrant of a force. Let me drop the last attendance. The equilibrant of a force. All right. The equilibrant of a force. The word equilibrant is from equilibrium. The word equilibrant is from equilibrium. When two forces is said to be in equilibrium, what does it mean? When two forces are said to be in equilibrium, how do you understand it, class? Lizzie, Yasmin, Jojo, talk. Leonard and Co. talk. If two forces are said to be in equilibrium, what does it mean? Do you have any idea? Jojo. Jojo, I'm listening. By the way, do you have any idea? Jojo, are you there? Elizabeth. Okay, Leonard, go ahead. Leonard, go ahead. Oh, yes. Okay. Yasmin, go ahead.
Please, I think that they will be opposites to each other.
They will be opposite to each other. Okay. That is Yasmin's view. Thank you so much. Please, any other view? Okay. So when we talk about two forces being in equilibrium, the word equilibrium comes from equal. Equilibrium actually comes from equal. Then it means that the two forces are equal. And when two forces are equal, their net, their resultant, okay, will be zero. On seesaw, where we have the pivot at the center, if Yasmin is here, if Lizzie is here, and if their weights are the same, there wouldn't be any turning effect. The beam will just be flat horizontal. Now, if I want to find the difference between their weights, WY, Yasmin's weight, minus WE, Elizabeth's weight, because the two weights are equal, what will be the difference between them?
0.
0. Okay. And when the net force, this difference is what we call as the net force or weight. So the difference between two forces or vector quantities is what we call as the net. When two forces are said to be in equilibrium, their net force is equal to 0. So when two or more forces or vectors are said to be in equilibrium, their net force is equal to 0. Either their net force, or you can also say that their resultant force is equal to 0. That's the meaning of equilibrium. So equilibrium condition is when we have a number of forces acting at a point. Okay, and their net force is equal to 0. Then it means that those forces are in equilibrium. Please, are you okay? Class, are you okay?
Yes, please.
Yes, please.
Now, let's also understand what we mean by equilibrant. The equilibrant. The equilibrant is a force which causes a number of forces to be in equilibrium. The equilibrant is a single force that causes a number of forces to be in equilibrium. This is force Yasmin and force Elizabeth acting on a body in other angles. So if this is the body, force Yasmin is acting due west. Fy. Force Elizabeth is acting due east. Fe. If Fy is greater than Fe, what will be the resultant or the net force? If Fy is greater than Fe, what will be the resultant force? Yes.
F minus Fe.
So Fy minus Fe. What will be the direction of the resultant force? What will be the direction of the resultant force?
In the direction of F.
Good. So it will be in the direction of Fy. Now, when this is the resultant or the net force, when the equilibrant force comes in, it will act on the resultant so that their total effect will be, the total force will be equal to 0. So once the net force acts in the direction of Fy, F net, when the equilibrant force comes in, it would cause the total force around to be equal to 0. And so what do you think will be the direction of that force which will cause the net force to be 0? What must be the direction of that force which will cause the net force or resultant force to be 0? What must be the direction?
Due east.
Good. Due east. And this force, which causes the net force acting on a body to be zero, is what we call as the equilibrant. It's what we call as the equilibrant. So usually the equilibrant.
Can you please come again?
Yeah, Mate. Today my voice is choked, so pay attention. The equilibrant force has the same magnitude and direction as the resultant force or the net force, but its direction is always opposite to the resultant force. Yeah, don't worry, you understand. We'll solve questions and all that, so you understand. The equilibrant has the same magnitude as the resultant, but its direction is always opposite to the direction of the resultant or the net force. The example again, I have two forces. Both forces are acting oppositely to one another. Force Yasmin, Fy. Force Elizabeth. Now I want to determine the net force or the resultant force. If Fy is greater than Fe, the net force is equal to Fy minus Fe. And the direction of the net force or the resultant force would act in Yasmin's direction because Yasmin is producing a greater force than Elizabeth. So F resultant would act here. Let me draw a single force diagram to represent the nets. So F resultant is here. This is the resultant force. Now, when the equilibrant comes in, it causes the total force acting around to be zero. And so the equilibrant must have the same magnitude as the resultant. So if this is X Newton, equilibrant would also be X Newton, but its direction is always opposite to the direction of the resultant. So once the resultant is acting due west, the equilibrant would act due east. Equilibrant. So in effect, the equilibrant causes the net force acting on a body to be zero. It has the same magnitude as the resultant or the net force, but its direction is opposite to the direction of the resultant. Yeah, are you okay?
Yes, please. Thank you.
Welcome. So if I have this number of forces, F1, F2, F3, and I'm asked to find that single force, which will cause the net force to be zero, then assuming that it means we have to look for the equilibrant. So let the equilibrant be X. Then it means that if I add all the forces, F1 plus F2 plus F3, and add the equilibrants, or F1 plus F2 plus F3. The effect of all this must be equal to the equilibrant. This is one way of expressing this, or F1 plus F2 plus F3 minus the equilibrant must be equal to 0. This is because the equilibrant has the same magnitude as all of these combined. So if you subtract the equilibrant from the resultant, it will be equal to 0. That is all that the equilibrant means. Let's pick a question and apply. Solving a question will bring understanding better. I'll take a shot of the question and then drop it on our platform. Angel. 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 Oh, she's not here. I've dropped the question, okay, in a group. So two forces, P and Q, with a given magnitude and direction. I think it's not so clear for me. I want to retake it. Okay, so it's dropped on the platform. Two forces, P of magnitude 6 Newton, acting at an angle of 60. Sorry, 4 Newton, acting at 60, and Q 2 Newton, acting at 100 and 225. They all act on the body at the same time. We are to find the magnitude and direction of the third force that will keep the body in equilibrium. So it means that we are to look for the equilibrant, that third force which will keep the body in equilibrium, its magnitude and direction. Okay. So we are looking for the equilibrant. And the equilibrant is that single force which will cause the net force on the body to be 0. So when you add the equilibrant, the net force must be 0. The equilibrant has the same magnitude as the resultant, but its direction is opposite to the direction of the resultant, implying that if we determine the resultant, we can also determine anything about the equilibrant. So let's see how to apply this. We have P equal to 4 Newton (60°) and Q equal to 2 Newton acting at 225°. So we are looking for the third force, which will let these two be in equilibrium. So let the third force be R. So I said that when you have a number of forces acting on a body or at a point, when the equilibrium comes in, the net force is equal to 0, or the resultant force is 0. So when I add all the forces, P plus Q plus the equilibrium R, the net must be 0. Or P plus Q must be equal to R. Please, are you okay?
Yes, please.
Now, let's resolve P and Q into various components. Do this and give me feedback. Resolve P first. You give me the components of P. When you finish, resolve Q, and then give me the component. Start work. Yes. What are the components of P? What are the components of P?
Two, three, and two.
All right. So 2 root 3 and 2. What are the components of Q? What are the components of Q? If you are ready with that, with a component of Q, share with me.
Roots 3 and 1.
Come again.
Roots 3 and 1.
Component of Q. Check again. Recheck.
Negative root 2 and negative root 2.
That is right. Please listen. If you are coming to punch, sine, cos, ensure that your calculator angular measurement is on D. There is this writing, okay, on the screen. D, R, G. This is whenever your angular measurement is in degree. This is radian. This is gradient. When it's supposed to be here and it's here, it will affect your values and vice versa. So whenever you are doing angular measurement, make sure your calculator angular measurement is at D. You see D written on the calculator screen. Else, you get everything wrong. And how do you do that? Press on, if you want it to be on D, press on Shift, then press on Mode on your calculator. If you press Shift and press on Mode, you see 3 for deg, 4 for rad, 5 for grad. Okay. If you want it to be on degree, then you press on 3. If you want it to be in radian, you press on 4. So whenever you are doing angular measurement, ensure that your calculator is on D. Else, every calculation will be wrong. All right. That is food of thought for you. So these are the components of P and Q. Now, either this plus R must be equal to 0 or this must be equal to R. And don't forget, R is the equilibrant, that third force, which will bring all the forces to equilibrium. All right. Let's add x's. So 2 root of 3 minus root 2. Then 2 minus root of 2 must be equal to R. Give me 2 root 3 minus root 2 in decimal. 2 root 3 minus root of 2.
2.049.
Okay, I want to confirm 2. All right, so that's correct. So we have R being equal to 2.0499. Then 2 minus root 2. Give me a class.
0.586.
Let me confirm. Zero 0.58. Okay, let's express it in 4D.
0.586.
858. I'm only expressing it in 4 dB as I did here. So these are the coordinates. Leonard, mute yourself. These are the coordinates of the equilibrants. Having had the coordinates, look at it. You redraw, draw the coordinates on the Cartesian plane as we've been doing. The x component is positive. Y component is positive. So they'll all be here. This is 2.0499. Then 0.5858. So you have two vectors, one here, one out. The resultant would act along the diagonal. Using equal vectors, you can find the direction of the, you can find the resultant and then the direction. Please do that for me. So R squared equals x component squared plus y component squared. So 0.5858 squared, 2.0499 squared. Let's hurry up. That is equal to what? Hello, that is equal to, oh, today your contribution is bad though. My voice is down and look at the nature of the contribution. Yeah, this is equal to what? Oh, Lizzie and Co.
4.545.
Please, let's not waste time in our responses, please. And the square root of this is equal to, the square root of this is equal to
2.132.
2.132.
so this is the magnitude of the third force, which will keep the body in equilibrium. What is the direction? The direction is this angle, assuming it's alpha. If you take the tangent of the angle alpha, this is 0.5858 divided by 2.0499. Help me find alpha. Help me find the value of alpha. Be quick in your response, please.
15.9483 degrees.
So approximately 16. Approximately 16 degrees from the east or or 90 minus 16. I think we found the resultant rather. P plus Q is equal to R. We resolve this into components and then sum them. This is by equating this to this is the resultant. Now we are saying that the equilibrant has the same magnitude as the resultant, but its direction is always opposite to the resultant. Okay. Now, so once we found the resultant, the equilibrant would have the same magnitude, but its direction is always opposite to the direction of the resultant. So if the resultant is acting in this direction, then the equilibrant must act here in the opposite direction. Now, how do we, for magnitude of the equilibrant, magnitude of the equilibrant, it must be the same as we had 2.3 2.13 Newton. The magnitude is 2.13 Newton. But the direction of the equilibrant, which will keep this in equilibrium, must be opposite. How do we determine that? You see, we found this angle had 16. By vertically opposite angle rule, this is also 16. Because this is 16, this is also 16. Now, if I want to measure the equilibrant from the north, meaning I have to stand at the north, through what angle do I have to turn to get the direction of the equilibrant? I have to turn through this angle. Now the whole of the angle from the north to this side is 270. So if this is 16 degrees, what will be this whole angle? Yes. Think through and then give me the answer. From Y or north to the west.
254.
Good. This is 270. So if this is 16, then what will be the angle from this point up to this? So we have 270 minus 16. And he said that would be 200 and what?
54.
54 degrees. So the third force, which will keep this in equilibrium, must have a magnitude of 2.13 Newton acting at an angle of, or at an angle of 254 degrees from the north. That is the equilibrium. All
Please,
right,
can you go?
come again.
Can you go over what we done for the direction of the
Okay, so
equilibrium?
the equilibrant has the same magnitude as the resultant. So what, by equating R to this, we are finding the resultant. Now, if you determine the magnitude of the resultant, that would also be the magnitude of the equilibrant. but the direction of the two are always opposite. Whilst one acts due east, the other one acts due west. So we have found the direction of the resultant, which is 16 degrees from east. It implies that the equilibrant must act in opposite direction. So if resultant is acting here, equilibrant would also act in the opposite. But what is the angle as measured from the north? Once this is 16, by vertically opposite angle, this will also be 16. But we are measuring from the north, and the whole angle from the north to the west is 270. So if you have the whole angle to be 270, and this is 16, then the remaining bigger angle will be subtracting 16 from 270. And that gives us the 254. And that is the direction of the equilibrant, which is opposite to the resultant. Are you okay?
Yes, please. Thank you.
Okay, I try one. I want to give you an example to try. Let me take a shot, then send it to you. You must have 0.5 P and 0.866 P. F2, when you resolve, you must have √2 or 1.414 and 1.414. F3, when you resolve, you must have 5 and 0 for X and Y. F4, when you resolve, you must have 0.5 Q and then minus 0.866 Q. Then F5, it is minus 8 and 0. Please, I'm sure you had the resolution of component for each one of them as I got. Hello, House, did you get this?
Yes, please.
Okay. So once you have this, the next step is that when forces are in equilibrium, then F1 plus F2 plus F3 plus F4 plus F5 must sum up to be 0. So go through this, add x's and add y's. Then we continue from there. So the next way out is this. Once you have F1, you sum all of them up. 0.5 P, 0.866 P plus F2, 1.414 F3, 50. F4 0.5 Q and minus 0.866 Q. Then F5 minus 8, 0, all this equal to 0 because they are in equilibrium. So you add all the x's, then you add all the y's. 0.5 p plus 1.414 plus 5 plus 0.5 Q. Now, the fact that you are equating everything to 0 means that this also has coordinates 0, 0. So this, all the summed up x's equal to a coordinate 0. Then you sum up all the y's. 0.866p plus 1.414 plus 0 minus 0.866 Q also equals a coordinate of 0. So add like terms. You can add 1.414 and then 5. So you have 5. This is like equation 1, equation 2. You have 5.414 plus 0.5p plus 0.5 Q equal to 0. Then 1. Okay.
So how about the 8? The minus 8.
Oh, thank you. I think I overlooked that. This. Oh, thank you. So minus 8. Let's rewrite it. Minus 8. So we have 5.414 minus 8. 5.414 minus 8. And that will give us minus 2.583. So 0.5p plus 0.5 Q minus 2.586 is equal to 0. Thank you so much. Here, okay. So here we have 0.866p minus 0.866 Q plus 1.414 being equal to 0. Now we are going to solve these two equations simultaneously. Okay. If we divide 2 by 0.5, we'll have equation. Hello?
So yeah, please, it's minus 1.586.
For equation.
It's not 2.586, it's minus 1.586.
5.414 minus 8. Right?
So please,
Hello? Hello? Oh, this is also 6.414. 6.414 minus 8. So that is minus 1.586. Yes. This is an indication that you are working with me. where I fail to look at, you correct. That is a good sign, okay? Because when you add this and this, you have 6.414. Thank you. So, because you are going to solve this simultaneously, you divide through by 0.5. So we have P plus Q minus divide 1.586 by 0.5. And this is minus 3.172 equals 0. Then we also divide through by 0.866. So in equation, let's call this equation 3. We have P minus Q plus divide 1.414 by 1.414 divided by 0.866. And you have a, okay, let's write 4dp 1.6328, and this is equal to 0, equation 4. Okay, so if you make any of the equations the subject, maybe let's make P the subject from equation 4. And P would be equal to Q minus 1.6328. We are sending this and this to the other side. So substitute this into equation 3. When you substitute this into equation 3, you have Q minus 1.6328 plus Q is equal to 3.172. I've sent the negative to the other side. So 2Q equal to 3.1.
Mr. Edger,
Hello.
please, what did you multiply the equation 2 by to get 1? What did you do to the equation 2 to get 1?
So what did I do to equation
2 to get the equation 4.
I divided through by, look at it, look at the equations. This is equation 1. This is equation 2. Okay. I just wanted to reduce their coefficient down. So I divided through by 0.5. So 0.5, 0.5, 0.5. So I have P plus Q. When you divide 1.586 by 0.5, this is the result. And that gives me equation 3. Are you okay?
Thank you.
Equation 2, I equally divided through by 0.866. So P minus Q. Then when you divide 1.414 by 0.866, this is the result. Okay. So 2Q is equal to 3.172 plus 1.6328. So let's add 3.172 plus 1.6328. We have 4.8048. Then you divide through by 2 to find Q. Q is equal to this divided by 2. And we have Q as 2.40. 2.40 Newton. Once you have Q, help me find P. And I left it this way because we're asked to write our answer in two significant figures. So it will be 2.4. For two significant figures, then the answer will be 2.4 Newton for Q. So find for P and leave it in two significant figures. What have you had for P? What have you had for P?
0.7672.
Okay, so for two significant figures. Okay, let's go through together. Okay, so I can use, once I have Q, I can use either equation 3 or 4. Okay, to find. So when I use equation 4, I have P equal to Q, which is 2.4 minus 1.6328. So 2.4 minus 1.6328. And I have 0 points, but I'm told to write my answer in two significant figures. So 0.77 Newton. So you see, the question looks loaded, but when you take your time, go through it step by step, it is not difficult. But please, over here, you need to be very, very, very careful, else you get it wrong. Okay, look at how you were even seeing things, correcting things. So it means that if you do this and you are not following every step carefully, you can get it wrong. So please open your eyes whenever you are giving such problem. It isn't so difficult. If you understand what you are doing and go through it step by step, it's a simple thing to do. If you have any question, ask. If you have any question, quickly ask. Is it? I hope it's clear to all. Because I'm going to send you another question. I'm sending you another sample. So you try your hands on it and then forward. Calculate the magnitude and the direction of the resultant force. I'm going over. A broken down vehicle is being pushed by 3 men with respective forces. 22 Newton acting at 30 degrees. 315 degree acting at 90. And 240 degree acting at 120 degree. Calculate the magnitude and the direction of the resultant force. And I'm adding another question. You are also to calculate the direction, the magnitude and the direction of the equilibrant force. Okay, so you are finding the result, the magnitude and direction of the resultant force. 2, you are also to look for the magnitude and direction of the equilibrant force. So you do this. When you finish, take a shot, please, and send it to me. But please do a step-by-step work so that when I'm following to mark, it can be easier. Some of you, I have that difficulty whenever I'm following the methodical, way of your work presentation. So do a step-by-step resolution into components, summation of them, blah, 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 so I can follow and mark. Okay? Send it to me on WhatsApp in your personal pages, and I'll be waiting. So this will engage you. We have 6 minutes to end the show. And this is where I draw the curtains on today's meeting. In fact, have a fruitful weekend.
Sir, please, what
Bye-bye.
am I supposed to submit?
Oh,
What
within
am
the
I
day.
supposed to submit?
Within the day. This is the deadline for this is today.
Okay.
Class, the deadline for this is today. Let me have it today, right? Okay, so I'll be waiting. Bye-bye.